Welcome back to this video on our series on ordinary differential equations. And now we're going to be dealing with questions under equation solvable by the separation of variable. And now look at the first question here. We have the x over x is equals to tan y dy. We have stuff like this and stuff like this. And you will notice that everything is not directly in the form of f of x is f of x dx is equals to another function of y, or no, let's do this way, f of y dy is equals to another function of x dx. Everything is not in this particular form. For example, this we have x on one side and y on one side, which is straightforward. But something like this, we have the y dx and we have y and x over here. Something like this, we are going to have to apply a little bit of algebra in it and stuff like this, indices and everything that we know. We are going to be applying it to it to be able to solve, put these questions into this form first before we integrate. So now let us look at the first question here. We have we have the x over x is equals to tan y dy. So now the first thing that you see x on one side and y on the other side, the first thing you just do is to integrate both sides. That is all. You add our integration sign, we add our integration sign to both sides. If we differentiate the x over x, it's like saying you want to integrate 1 over x dx. This is the same thing as this. So this is just going to give us ln x, and we're going to be having our c, or we can put it as ln c. Either way, it's still a constant. So now we have it as this and equals to. Now when we integrate tan y, we need to understand the concept of integrating tan y. First of all, tan y is equals to sine y. Let me put it somewhere here. We have tan y is equals to sine y over cos y. And if we are to integrate something like integrate tan y, that means we are integrating sine y over cos y with respect to y. So we can just make cos y the bottom. We can make y, we can use substitution formula to solve this. We'll make u is equals to cos y, and therefore the u is equals to, if we differentiate cos y, we are going to have minus sine y, and we have our dy as what is here. So now that means our dy is equals to du over minus sine y, and we can bring the minus here upward. So if we differentiate something like this, so therefore we are going to be having an integration of sine y over our cos y is equals to u. We have u here. So then our dy is equals to minus du sine u, that is times minus du over sine u. So we have sine u cancel sine y here. Sine y cancels sine y, and therefore we are going to be having this as minus the integration of du over u, whereby we have our u as cos y, and at the end of the day this is going to be giving us minus ln u. So our u is equals to cos y, so therefore this will be equals to minus ln cos y. So now this is what the integration of tan y is going to be giving us. So that means here we are going to be having minus ln tan cos y in brackets. So now this is what this is going to give us. So now if we try to simplify it, if we try to simplify it, we can say we want to bring x and y to the same place. So we just have ln x, then we have plus ln cos y is equals to ln c. then something like this. And if we know logarithm rule, we can just add them together. We have ln into brackets x cos y equals to ln c. And we use this particular law that e raised power ln of a function x is the same thing as x. That is, the e will cancel the ln. So we add e to both sides here. So e cancel ln, e cancel ln. So therefore we have x cos y is equals to c. So now this is the final answer for this question number one here. So we have this as our answer here. So now let's move on to the next question. Let's move on to the next question here. Let's move on to the next question. So now we have the y, the x is equals to our square root of 1 minus y squared over our square root of 1 minus x squared. So first of all, whatever, we need to put y in one side and x in the other side. So therefore, we just like kind of like cross multiply or stuff like that. We bring y here, we bring x to this place. We are going to be having the y over the square root of 1 minus y squared is equals to the x over the square root of 1 minus x squared. Now, this is what this is going to give us. And what we go, since we have y in one side and x in the other place, we just integrate both sides. And when we integrate both sides, you already know what we're about to do. Now, if you know trig sub very well, we'll know that when we integrate the square root of 1 minus y squared, it is going to give us the arc sine of y. And if we integrate the square root of 1 minus x squared, it is going to give us the arc sine of x. You can do the provings in, you can do the provings at all, or let us just move on. So now we see if we integrate this, we have arc sine of y is equals to, here we are going to be having arc sine of x plus c. And you know, this is our final answer. If you go and check the book of integrals and stuff like that, you are going to see that this is equal to this and all. So now we have already solved the answer to number 2 right here, and now we move on to number 3. Now in number 3 here we have the y, the x is equal to e raised power x minus y. Then we have plus x squared times e raised power minus y. X squared times a raised power minus y. So now if we use the law of indices here, first of all, we do not want the x and the y to be mixing up with each other. So we need to separate the y from the x. Let's use the law of indices to break this down. We can have this as the y, the x is equals to e raised power x multiplied by e raised power minus y, if you agree with me. Because we know at the law of indices, if we have, according to the law of the indices, if we have x raised power n multiplied by x raised power n is equals to x raised power n plus n. So we can just bring this back to something like this, which is from this to this. So then we can continue with our plus x squared e raised power minus y. Let me put that in brackets. So now we can see that e raised power minus y is common on both sides. So we can have the y, the x is equals to, we have e raised power minus y to e raised power x plus x squared. Now, nice for that. And since we have been able to differentiate this, let's put our x on one side and our y on the other side. So here we are going to be having the y over e raised power minus y is equals to e raised power x plus x squared the x. So now we know e raised power minus something is like saying 1, let's say we have x raised power minus 2 is like saying 1 over x squared. So in this particular case, e raised power minus y is going to become something like 1 over e raised power y, where the e raised power y is going to eventually come up. So we are going to replace our e raised power minus y is going to become e raised power y dy is equals to into brackets e raised power x plus x squared dx. So we just add our integral sign to both sides. If we integrate e raised power y, it's going to stay the same. It's going to be e raised power y. And if we integrate this, e raised power x is still e raised power x. And x squared is equals to plus 1 over 3 x cubed. Then we have our plus c. So now right here, this is equations that are solvable through separation of variable. Now, hope you have understood the concept of separation of variable, and in our next video, we are going to be going into homogeneous equations. Thank you very much.